Hello everyone. Before starting off the today's solution, I just want to share that who was new to the channel, we have started a new OA series. We are constantly pushing videos into it. This series is meant for the people who are preparing for internships and placement and who are struggling to solve OA questions. These series is tailored for these type of people that this compromise of good problems. Even if you are preparing for good hard interviews as well, right? The series will help you to solve these particular question. It creates that same environment that a particular online assessment or interview has. So do check it out this series and do let me know the feedback. Okay, let's start today's problem. So this problem is quite lengthy, and I would say the problem is very good in both in terms of thinking. If you write an optimized solution, and it's an implementation heavy problem. It's a implementation heavy. Sometimes what happens is we know the logic, but it's a the implementation is quite too. I don't want to do it. It feels like, but it does not happen in online assessment or interviews, right? You have to implement it. So sometimes you have to find some quick methods and good methods of implementing that will reduce your burden, and then that will, if you have to think more in that case, right? So we'll see what is the best implementation, what we can do for this particular question. We'll try to do that and let's try to see. So what we are given, we are implement a spell checker that converts a query into a correct word. So LeetCode is giving us hints, okay, means applying DSA again in real life. We have seen yesterday's contest as well, right? So for given query word, the spell checker handles two categories of spelling mistakes. What? Capitalization, by the way, we have also uploaded contest solution last yesterday itself, so do check it out that as well. Link is in description. For a given query, the spell checker handles two categories of spelling mistakes. Capitalization, if the query matches a word in the word list, case insensitive, then the query word is written with the same case as case in the word list. Okay, what does it say is that, see, there are many cases when you are writing words, right? Either you write the perfect word, either you write the perfect word. If you write the perfect word, no problem. Just just return the same word in the query, as they also mentioned downwards. That when the query exactly matches a word in the word list, case sensitive, you should return the same word back. Okay, then no problem. Then there is no need of spell checking, right? Cool. But problem arises when you start making mistakes. The first mistake you can do that you mm, just capitalization issues you make. Let's suppose you wrote this yellow, YELL, capital OW. Okay, but in the actual word, what's the actual word list we have? It's need not to be all always lowercase, but they all mention that what is the word list. What should be the exact wordings? It should be like this, but it closely matches to this, right? Why? Because only the capitalization is a problem. So fine, no problem. So what you have to do, whatever is the closest and the first occurrence that is correct of capitalization, you should return that. So you should return yellow. Had it been Y capital yellow in the word list, you have to return this. So I hope you're understanding the problem. Cool. Then they are specifying, okay, yellow is there, then you will return yellow. Okay, query they also mentioned. Also, yeah, I just mentioned this. So if this is yellow, but if they want this one, so you have to return the capital Y yellow. Yes. Right. Whatever is in the word list, you have to do that. That's your first thinking process. Cool. Then what is the other kind of error? That's other kind of error is vowel errors. If after replacing the vowels of the query with any vowel individually makes matches the word in the word list, case insensitive. Also very very important. Let's say you wrote by mistakenly YOLO, right? Does it matches with the any word in the word list? How would we check about it that? Only just care about non-vowel words, right? Oh, Y matches with Y, L matches with L matches with L, and also case insensitive does not matter, right? So yes, it does matches. We are ignoring the fact that vowels are there, right? But there's an important thing. You cannot ignore completely. Structure should be same. That it should not happen like this. That yellow is there and you have a YOL W, right? You are checking this is a fine, but this should something corresponding to a particular vowel only, right? Then it will only we can say. So these are not a correct vowel error. Okay. And then they are giving different case of examples. I already mentioned that it's a size greater, right? Then there's no match. Then finally, what they are trying to say, they created a tree type of thing. Okay, what are the cases what you have? So case one, see, you given a query. Now, what are the possible cases? It is the exact perfect match. It's a perfect match, right? So if it is a perfect match, return that word itself, s itself, whatever. Now it's not, then there are two possible cases. What are the two possible cases? Either it is a capitalization error, capital error, or whether it is a vowel error, vowel error. Okay. If 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 it is a capital error, you will give the priority to. You will check in this particular order itself. So if it is a capital error, okay, fine. You will return the closest first, not exactly closest, but yeah, you can say first correct capital word, whatever there in the word list, obviously should be present in word list. Be present in word list. Okay. And similarly here, right? The same thing. And then I already mentioned, okay, what is a over error and all. Okay. So what does the first thing comes to your mind when you see this kind of problem? Firstly, "Oh, I don't want to do it. This is simple. Let's just implementation. You're right. But you have to implement this, right? And this is an exact scenario. What happens in an industry? Then you have to implement something simple, but something lengthy. Okay. So what first thing that comes to my mind is very simple for the capitalization thing. See, I will create a map. Why map? There are three type of things, right? So I will create a map firstly, and let's see what could happen. The first case, if I hit perfect match, so if I found the word in my map, then my query is resolved. The query is resolved. I just divided my query into three categories because these are three possible answers. And also the fourth category is we don't find all of these, so we'll return an empty string. Query. So find it directly, completely, exactly, then we'll return that directly. So this is solved. So I think the perfect match is very simple to solve. Just keep all the elements, strings in the map, and then it's over. Okay, this is fine. About what about the capital thing? Now, capital thing has many problems. Let's try to see how we can do that. See, either what you can do is you can iterate an entire string. The problem is because why we have to iterate on the entire string, because we have to return the first string that is same as the our query string by just ignoring the capital letters. But do we have to do that? Think about that. The first intuition is, yeah, just checking it, just checking, ignoring the capital, just converting both to lowercase and just run a loop from, let's say, your other ith string, ith query. You go from j is equals to I plus 1 to n, and just check this both to lowercase. If they matches, then return the word list word. Right? This is a brute force you can think of. Every time you have to do this. Is there a better way? Can we pre-compute something? What do you think? There is. How there is a better way? See, this is a obviously a thing that you have to convert your string into lowercase. That too you have to do. Convert your string. And that won't into lowercase. And that's won't a problem. Why? Because the string size is only 7. So you can do it anytime, every time. But you cannot iterate on the word list. That is 5,000 words, and that's bad. Okay. Then what you do? Then what you do? Then you will check. Then you can again create another map of string comma string. I will tell you why string comma string. This is also very interesting. Of, let's say, case insensitive. Right? How it will help us? So what you're gonna do is you will check. You will convert your original string, let's say s, into lowercase, and then what you will check whether this is present in my map itself or not, right? Yeah, that means if it is present in my map, if it is already present in my map, then to ignore it because we already found a particular valid key corresponding to our lowercase. So we don't need to do anything. Else, insert this key, insert this lowercase key. What I mean by that, let me show you with the help of example, right? What I mean by that. See, let's say you have yellow as a query came to you, and this is a query. Okay. What you have in the word list? In the word list, you have L, L, sorry. This is like YELLOW. First, there are two words actually. This is the word W, and the other word is YELLOW. Does both of them satisfy the query? Yes, both of them satisfy the query. No problem. In terms of the capital error, it is. But would you ever go to this? No, while you will go because it's the low. If you can check the lowercase of this and then check the lowercase of this is fine. You will return from here itself. You don't need to go here. That's what I'm saying. You convert the string into lowercase, and if it is already present, then you don't need to do anything, right? You when you reaches here, just skips this because you already find the particular string corresponding to that. And what you gonna store in your map, insensitive of the lowercase key, your whatever lower you have converted, it's your original string in the word list, word list string, which is here capital, this one. So this is how you can do that. And this is how in you have pre-computed this in for loop previously, right? Where you're calculating the map of the strings. You can do in the same loop itself, and then you can answer any query in O of one now. You get it? Right? You can just take the key out of it. Oh, if this insensitive is present, like this lowercase key present in my map, that means there exists a capital letter I can resolve with the help of capital letter itself. Okay, and then I will return one. These two queries are resolved. I hope you understood it. Now the interesting thing, the most beautiful thing, vowel error will come, and I will show you a very beautiful solution that will blow your mind. Actually, the vowel error. Now it could happen, right? It's not a capital error itself, and it's not a vowel error itself. Vowel error. Okay. So let me just show you. So what you're gonna do is you have a vowel error. Now it's very simple. See, the problem is now you have to replace vowels with any vowel. You can do that, and also case insensitive. So first thought that come to my mind is what do you think about that? Ignore vowels, ignore vowels, literally ignore vowels, right? You create a new string out of your original string, ignoring the vowels, ignoring the vowels. Let's say it's your original string is keep. You can make a new string, just kt, obviously in lowercase also, that that's efficient for checking, and this is your new key, and then you can create another map, another map of vowels. Again, string comma string, right? Which is the query matches in the word list. So let's say vowels, right? And then we will again check the same thing whether this particular key is present or not. If it is present, then map it to word list string. Similarly, what I mean by that is, let's say I got like this k o coot came, and then I have in my it is like k e e t, and then it may be like k a a t. Both satisfy the query, right? Both satisfy the query. But what we need the first occurrence that satisfy the query. This is the thing. But very important to understand. Is it like this? Do tell me. I deliberately wrote this because to explain you the major concept here. You can ignore the vowel. That's perfectly fine. But you cannot ignore the structure. So You have to create a common character for each vowel. So let's say you can keep a hash. So your key should look like this. Hash. This should your be the key. This is the most important point in this. Most important. Why we have made the hash is very important, because the structure is very, very important. How you are placing the vowels, only not the size. The structure is also important. Where the particular vowel is coming, you can replace with any vowel. It could be capital, it could be lowercase. No problem with that. The main problem is that you have to ensure that the structure is same. Then you can just check with the lowercase. You create this in the lowercase. You create all the string already in the lowercase. We already did that, and just compare, and whatever is the same logic, we did that. If you already find this present in my map, then don't no need to do the anything. If it is not, insert the particular this key. Insert this key. So I hope you understood the concept and the intuition what I've told it in all the three queries, and the complete solution I solved in O of n. This beautifully I did that. O of n into 7, you can say that the string length, maximum string length, which is 7 only, so which is O of 7 itself. O of n itself, sorry. Let me also go through the solution, and then we'll see one example as well. So yeah. So two functions we need: make lower to convert a particular string into a lowercase. There's no standard function in C++, so you have to do that manually. So we did that. There's a two lower character function that convert a character into a lowercase, that we converted this into a lower string. And also there is a is vowel function. We have to write that given a character, whether it is a vowel or not. Here also it's very important. It could happen that C could be lowercase or uppercase, so we have to handle both the cases. I just wrote C is equal to C dot lower, so I handled both the cases perfectly. Right. I created three maps. Why unordered? Because we don't need to care about the sorting thing. We just need to create a map. And an order map has good complexities, no extra log and factor of O of one, O of one, and O of one complexity average, and best case complexity it has. Worst case is O of n, but that's not worry about that. Right? Created three maps. The first one is for the perfect match. This is for the capital error, and this is for the vowel error. Right? So what we gonna do? We are pre-computing the stuff. The first thing is directly adding this into our MP. That this exactly is there. If it is there, we'll just return the same string. Now the start thing started from the second string. What we are doing, converting our string I into a lowercase, right? And then we are checking whether this particular lowercase key already present in our word list, not word list, in our insensitive map. Insensitive map is not present, then we'll insert it. By inserting means just creating a key value pair, insert of S, that whatever lowercase we key have, and this is the corresponding word list, original word, right? We need to return the original word, that is I. Okay, this is fine. Second query done. That type of query done. This is the third type of query. Without vowels, we'll create a string, new string out of a original string. But the obviously in the lowercase string we did directly. Why? Because I already told you, they already mentioned make vowels. They could be insensitive, case insensitive as well. That's why we're doing in the lowercase. So directly. Then we are checking if it is not a vowel, then just directly add the character. If it is a vowel, don't ignore it. You have to add a hash, or you can add whatever exclamation mark. It's your choice, but the structure will make it different, right? Now we'll check whether this without vowels is exist in our vowels map or not. If it is does not exist, we just create one more entry, and we did the computation. It's pretty simple, right? It's very simple implementation with that. It's very simple. Just you have to think about before implementing. Right? Then what is it? Final answer we calculate. If we directly find our answer, the query type one query, directly find exactly in our MP itself. So just return it. Fine. The other thing, if it is fine in our insensitive, that we obviously have to convert this query into lowercase first, right? To match. If it is found in our insensitive map, oh, it's very simple. That finally push into our answer vector. The insensitive value, what we have, the this will corresponding to the value in the word list vector. Word list vector, right? So I hope you are getting it. And then what we gonna do? Third case, third case, if it is not in insensitive map, means it's not a capital error anymore. So let's try to check whether it is a vowel error or not. If it is not, then obviously we have to return an empty string. So without vowel, we'll construct the same way. We convert first in the lowercase, we'll construct the same key, and then we'll check. Firstly, we'll check that it is present. If not present, then add it. If it is here, we'll check if it is present, then only just push the value. Otherwise, just push the empty. It's a beautiful, beautiful question. You should understand that. And if you have any doubts, do let me know. Also, let me just walk you through some a good example, that this example itself that will make you things more clear. Okay. So let's try to do that as well. So let's try to quickly go through this example. And if you are still here, so do hit the subscribe button and like the video, because it's make took efforts to make this kind of videos, right, for you. So the kite is here. This is the word list. No worry about it. We will compute it. Let's say everything. Let's go with kite first. Does kite exactly present in our vector? Yes, the kite exactly present, so no problem. Now we will go about this. Whether it is a perfect match? No, it is not a perfect match. When we go to capital thing, we'll try to make it lowercase. We make it lowercase. Oh, did we find anything? See, this is the first thing that matches with this with the lowercase, right? We converted everything into lowercase. We'll return the kite because it's the first entry. Fine, fine. We were not going with this. Mind it. We're going with this, right? Because this is the first entry. Then we are going with this, exactly finding it. So we'll return returning this. Fine. Now we are going with here. Now see, it is not. It is a capital error problem again. So what you gonna do is, what you gonna do? Here is exactly present. Actually, it's not a capital error problem. It's directly present here. So directly returning here. Here it is also directly. Is it directly present? So let me just check about it. So the query is HRE here. So here it's directly present. Here capital it present. The spelling is same. So what we return, this one, right? Why? The capital error is there. There's no vowel error until now. Now the vowel error will start to come. And let's try to see. Here it comes. Okay, it comes here. HEAR. There is no way the structure is matching anywhere. See, we have HARE and we have HARE, but we got a query as here, like HEAR. And I already explained you the structure should be same. The key corresponding to this we have is H hash R hash. And for this it is H same hash R hash. What fun when we calculate for this hash hash R, they're not matching, right? That means we don't have anything in our vowels map, so we will return an empty. Same way we go for it with here. It's again there's no thing, same key will be created, so it won't be there. KT will create a map. Okay, the KT created map is K hash P hash. Is there anything? Yes, yes. Do for this. The same map is right. Kite will come. Similarly for key, you just do a K hash hash. For this, does nothing happens, right? Because this the key is K hash hash T. And the hour for this, the key actual this is the key. And this is the query key. Q key. So this is not exist, this exists. But this keto will exist. Key hash T hash. So that's why the hash thing helps us. I hope you understood the entire intuition, the entire code base, how I implemented it beautifully, the entire thing, why I do that, how I reduce the complexities, and how I solve the problem in a stepwise manner. So if you like the solution, make sure hit the like button. Do check it out the way series and see you in the next video, guys. And also check out the LeetCode solution as well.